T is the 20th letter of the alphabet, and 20 starts with T. Are there any other letters with this property? Let's find out. So let's start with what we know. 20 goes to T, goes to 20. And everything else that starts with 20 also goes to T. And so do a few other numbers. There's 2, 3, 10, 12, 13, and that's everything. Let's start again with another letter. How about S? S is the 19th letter. 19 starts with N, and this is becoming a mess. Let's find a different way to do this. If we start from the bottom, it'll organize itself. So T is the 20th letter, and 20 starts with T, and so do several other numbers. There's 2, 3, 10, 12, 13, 21, 22, 23, 24, 25, and 26. But what about the rest of them? Where do they fit into this? Let's start again with S. S is the 19th letter, and 19 starts with N. N is the 14th letter. 14 starts with F. F is the 6th letter, and 6 starts with S. So we have another closed loop. And other numbers come into this at all different points. Starting with N, we just have 9, so I comes in at that point. Starting with S is 7, 16, and 17, and starting with F is 4, 5, and 15. Look at that symmetry, isn't that nice? Just kidding, there's more. Starting with E is 8, 11, and 18, and finally, starting with O is 1. One thing that surprises me about this pattern is that it's split up into two sections of almost equal size. I would have thought maybe one of them would only have a few and one would have most of them, or something like that. And I guess sometimes the fixed loop only has one letter in it, and sometimes it's bigger. And I'm also surprised by how flat the T structure is. I would have expected more ups and downs, like in the NFS loop. But what if we try using the last letter of each number? So 5 ends with E, and E is the 5th letter. And also ending with E is 1, 3, 9, 12, 21, 23, and 25. And ending with Y is 20, and ending with T is 8. So that's this whole section, and now let's find another fixed loop. There's N and 14 again, but this time by themselves because 14 ends with N. And also ending with N is 7, 10, 11, 13, 15, 16, 17, 18, and 19. And ending with O is 2 and 22. And ending with R is 4 and 24. And ending with X is 6 and 26. And that's all of them. So I'm also surprised. I'm surprised that they both have two groups of such equal size. But I'm starting to think that maybe it's more common for the fixed loops to only have one thing than for them to have more. And I'm not surprised to see more irregular ups and downs in the heights. We're also seeing some etymological convergence with these patterns, where words that start or end with the same root word tend to be grouped together. For example, we see everything that starts with something related to the word to all being grouped together. And yes, 20 and 12 are both related to the word to. They start with T for the same reason. And we also see the 3s lumped together, and the 4s, the 5s, 6s, 7s, 8s, and 9s. And on the other side, see everything that ends with 1 is together, and so are the 2s, 3s, 4s, 5s, 6s, and 10s. And yes, the teen is related to 10. But who says we have to do this in English? Other languages have different words for numbers, and that could change the whole structure of this. So for reference, since we've been working in English, I'll label the original set as British and the weird backwards derivative set as American. So what other language should we try? Spanish is a good one. I'm familiar with this. Spanish only has one fixed loop, and it is based on that V is the 23rd letter, and the Spanish word for 23 is 23. Sorry for my pronunciation. And that starts with V. And you may be thinking, hang on, V is the 22nd letter. But it isn't in Spanish. They have a different alphabet than us, kind of. When Spanish has an accent over a vowel, that's just that letter with an accent. But Enye is different. It's not just an N with an accent over it. It's a separate letter, and it's the 15th letter in the Spanish alphabet, right after N. So everything after that gets shifted over by one number. So what else starts with V? It's just the other numbers that start with 20. So there's S, T, U, W, X, Y, and Z. And starting with S is seis and siete. Starting with T is trece and tres. And starting with U is uno. Now for the fourth layer, starting with C is cuatro, cinco, and catorce. Starting with D is dos, diez, doce, and a bunch of other numbers that start with diez. And starting with N is nueve. And we have a new height record. This is the tallest tree we've seen so far. But we're not done yet. There's one more layer, because starting with O is ocho and once, and starting with Q is quince, which gives us enye. So this is pretty different from what we've been seeing so far. I guess just because there's only one fixed point and everything goes into it. But it's also kind of top-heavy. Like, a lot of stuff is on top of C and D. So what other language can we try? How about Hawaiian? The Hawaiian alphabet is nice and small. It's similar to the English alphabet, except with most of the letters missing. Except that this isn't the Hawaiian alphabet. This is. It's because they have it in a different order. They took all the vowels and moved them to the front, and they also have this apostrophe-looking thing called okina. and that represents a glottal stop in their language, which is why Hawaii is sometimes pronounced with a break between the two I's. And that is a real letter, and it's 13th in their alphabet. So what kind of beautiful structures can we make with such a small alphabet? Well, it turns out every number word starts with Okina. So it's similar to the T structure from British, except it's the entire thing. But what if we cheat and pretend Okina isn't real? It's just an apostrophe after all, right? Well, it doesn't improve much. Every number word that's not derived from 10 starts with E. So, we can't cheat. This is the real Hawaiian tree. It's nice the way it is. Okina is a real letter, and we can't deny that. It only looks weird because the English speakers who created their alphabet didn't have a letter for that sound that was common in their language, so they just gave it punctuation because it seemed unimportant. So, here's Hawaiian. And what other languages can we do next? No, there's way too many letters in this language. Are they even letters? I don't think so. We could do Russian. Actually, that looks like a lot. Does Inuktitut syllabics even have an order? Okay, I could do Greek. I'm familiar enough with this. It only has 24 letters, and it's reasonably foreign, but there are some familiar looking things. And you may be thinking, some of these look different from how you remember seeing them. And that's because some of them you mostly see in lowercase, but they look different when they're capital. So, how can we arrange these? The fixed point, again, involves T. Actually, it's tau, which is the 19th letter of the Greek alphabet. The Greek word for 19 starts with delta. Delta is the 4th letter, and the Greek word for 4 starts with tau. And also starting with tau is the Greek word for 3. So that gives us gamma on that side. And on the delta side, we have beta, kappa, mu, nu, xi, omicron, pi, rho, and sigma. And starting with omicron is the word for 8 because it's like octo. So that gives us theta. And starting with pi is the Greek word for 5 because it's like penta, and that gives us epsilon. And then everything else starts with epsilon. So there's alpha, zeta, eta, iota, lambda, upsilon, phi, chi, psi, and omega. So this looks even more top-heavy than Spanish, but kind of neater in a way. And we finally found another fixed loop that has more than one letter. It's still not as big as the NFS loop from the British system, but it's good to see that a size bigger than 1 isn't unique. So, what have we learned from all this? Well, I think basically nothing. But this was the last thing on anyone's mind while these languages were developing, and it's interesting to see what kind of patterns can fall out of something like that by accident. So this is by no means an exhaustive list. It's very, very unexhaustive. So let me know if you find any more interesting things related to this.